Okay, we have a 3D question here. So a right circular cone of height 12 feet stand on its base, which has diameter 8 feet. So you have a cone. This is not by scale, by the way. I'm just drawing this roughly. So this has a height of 12 feet. Everything is in feet, so I'm not writing feet every time. And the diameter is 8 feet. Right. The tip of the cone is cut off with a plane which is parallel to the base and 9 feet from the base. So from base, you cut off, from the base 9 feet, you cut off parallel to the base. So that the cutoff part will be another cone, right? And just use similarity here. So if this is 9, this is 3, right? So the original cone and this cone have their heights in the ratio 1:4, isn't it? So this is 3 and this is 12. So the height are in the ratio 1:4. So the, let's say, the cutout cone and the original cone have their heights in the ratio 1:4. And if that is the case, then the volumes, similarity tells us, will be in the ratio 1:64. Now we are looking for the volume of the remaining part. So this frustum is what we are looking for. So the volume that is left out will be 63 by 64 of the original cone, right? And the cone, a cone has a volume of 1 by 3 pi r square h. Pi we have to take as 22 by 7 as instructed, and r is 4, by the way. This is a diameter 8, so that is 4 square 16 into height is 12. So this is of the original cone, right? So you have this much fractional volume remaining of this cone, so that will be the volume of the first one. So let us quickly do the cancellations here, whatever we are having. So let's check this out. So 3 into 7 is 21, so this goes off with this, so you'll have 3 here. And so 12 has 4 into 3, right? So 16 into 4. If I take the 4 out of this 12, so 16 into 4 is 64. So that will go off, and you'll have another 3 remaining here. So that's it, right? Denominators are all gone. So 3 into 3 is 9. 9 into 22, 198. So that should be the answer here in cubic feet. So that's it for this question. Nothing too much to do. If you understand similarity, it's a very simple problem. Roughly 1 minute should be required to solve this question. You should not be taking more than 1 minute to solve a question like this, because some mensuration problems you have to, when I say mensuration, I mean 3D especially. So when we have 3D questions, some of them you will have a bit of analysis to do in terms of angles and everything. But this is a very straightforward question, so you should do these kind of questions very easily. Don't leave the basics. So as I keep on saying every time, and definitely this is a round one question. I mean, although it's a 1 minute question, but this should be done in a minute or something. You may go to round two thinking that the calculation might be tough, but put it in this way: in CAT, you would never have a question which will be theta type and it will be too calculative. So that will always have an option with it. So keeping that in mind, you can take a call, or if you're not very sure, then maybe you can do it in round two. But definitely a doable question, this one. So that's it for this question. Thank you.